Okay, good morning for those in Americas, good afternoon for those in Africa and Europe, and good evening to those in the East. Welcome back to the Cooperation Colloquium. For those of you who are joining us for the first time, the Cooperation Colloquium is a talk series featuring interdisciplinary speakers talking about research broadly related to the topic of cooperation. To kick off the talk series this semester, we are very happy to have Cailin O'Connor, who's a professor at the Department of Logic and Philosophy Science at UC Irvine. She specializes in the philosophy of biology and behavioral sciences, as well as evolutionary game theory. And she's the author of the book, The Origins of Unfairness, where she explores how we use social categories to solve coordination and resource division problems, but at the same time create inequalities among the social categories. Related to the topic of the book, the title of her talk today is Dynamics of Inequality. Before we start, if you have short clarification questions during the talk, please just unmute yourself and raise the question. And let's postpone all the questions that require longer discussions towards the end of the talk, where we would have around 15 minutes of Q&A time. Now, without further ado, Cailin, it's our pleasure to have you here as our first speaker of the semester, and the floor is yours.
Well, thank you so much. I'm really delighted to be here and to hopefully get to, exchange some ideas with some of the folks in this group. So yeah, as mentioned, I'm a philosopher of science. So I'll just jump in here, and I thought I'd say like a little bit about like what I do and why I would be here given that discipline. So I do a lot of work that involves building social models and then using them in philosophical or social scientific argumentation. And so there's different areas I've been working in. One bigger project looks at network models to understand the spread of false beliefs and then other epistemic failures like polarization. So I have this project where we model both scientific communities, so like literal communities of scientists, and then larger communities to try to think about that. And then, as you mentioned, the work I'm discussing today draws on this different project. So I published this book in 2019, The Origins of Unfairness. And that book uses models in game theory to consider the emergence of unfair or unjust norms, especially related to social categories. And it sort of has two halves. So one looks at how you might get the emergence of gender and certain types of like unfair gender norms related to the division of labor. And then the second half, which is really more what the stuff I'll talk on today is related to, looks at how you would get norms for unfair divisions of resources. And so in this book project, my group developed a long 8-year series of interrelated research projects, some of which are just finally tapering off now. So this is a project that's mostly wound down, but there's some last little like tailing things, and some of those, are all discussed today. All right. So why would a philosopher be working on this? There is this game theoretic tradition in philosophy considering how what philosophers call social contracts, which I think are best understood as patterns of behavior solving different sorts of social problems, could emerge through natural processes of social interaction, of learning, and of cultural evolution. And this tradition actually goes back pretty far to philosophers like Jacques Rousseau, and David Hume. And it looks at a number of different topics. So using different models in game theory, like the prisoner's dilemma to think about altruism, the stag hunt to think about cooperation when cooperation is risky, to think about norms of communication, and most importantly today, to think about resource division. And in this literature, philosophers sometimes call these emergent social contracts natural social contracts. So what I'm going to do today, the main aim, is to overview a bigger body of work arguing that counter to some previous claims, the sorts of natural social contracts that tend to emerge in human groups shouldn't be expected to be fair or just or equal. And so throughout, what I'm going to do is draw on evolutionary game theoretic models. So models assuming you have some process of cultural interaction, cultural evolution, of the emergence of bargaining conventions or conventions of resource division. All right, so here's a little roadmap. So first I'll introduce the model that I'll use throughout today, the Nash demand game. Then I'll talk about previous work showing how when you have groups evolving to play this game, they tend to learn fair bargaining conventions. So that's the kind of previous work and setup. Then in part 2, I'll describe why, despite this previous work, fairness is not actually what we should expect in evolutionary bargaining models. Basically, the section will argue, well, there's something really important missing from the previous models. That something is social categories. And once you add social categories to the models, you're going to get unfairness evolving generically instead. Then in part 3, I'll talk about the role of power in unfairness and its evolution and draw out relevant lessons for thinking about the emergence of these natural social contracts or patterns of bargaining between human groups. All right, so that's part 1. So as I mentioned, I'll be talking about the Nash demand game today. So this is probably the most widely used model of bargaining or resource division in game theory. Sometimes people describe this version of the game as divide the pie. So you could imagine the strategic scenario as something like this. You and a friend have a pie and you're splitting it and you each want to get as much as you want. So you're going to make claims for how much pie you'd want to have. And then if you can make compatible claims, you get what you ask for. If they're incompatible, if you both want too much pie, you're going to have a bad outcome. So maybe you're going to argue or fight over the pie, hurt each other's feelings, waste some pie. So if you think about like what you would do in a strategic situation like this, you might think, well, I'd ask for half the pie. If you don't think that, you're an unusual human, but maybe you think you would. We'll come back to that in a second. But basically, the strategic scenario we're talking about obviously is not literal pie division, but it's something like this. You have 2 individuals, you have a resource, they have to divide the resource in order to use it. They each want to have more, holding other things fixed, but if they're jointly too aggressive, they can't successfully divide it. So this kind of scenario is fairly common in human groups. And so this model has been used to represent bargaining over salaries, over international trade agreements, over labor in the household, etc. All right, so what are the predictions for this game? So this game has an infinity of Nash equilibria, which is every pair of strategies that perfectly divides that resource, like you get 70 and I get 30, or you get 8% and I get 92. These are the Nash equilibria because if someone changes strategies in this game, they can either ask for more or less. So if someone asks for more and you have it perfectly split, you'll just be over demanding the resource and you'll get this poor payoff. If someone asks for less, they just get less. So the first basic prediction is that actors will perfectly divide resources, but that there are a lot of ways they could do it. And the Nash equilibrium concept on its own doesn't select one of those ways. There are a lot of refinements in economics that then, make a selection. But this fact on its own sort of, sorry, what am I trying to say? It posed a puzzle for people in philosophy and some people in economics as well. And here's the puzzle. You have this surfeit of equilibria. In spite of that, when you look at experimental settings, people very typically arrive at the 50-50 split. And often they don't even have to go through like a process of learning to do that. Often they just demand 50-50 first thing when they play this game. So there's that. And then additionally, a lot of cultures have stated norms of fairness supporting the 50-50 split. So if you present them with this game there's no context, you just have a resource, you're going to divide it. A lot of people say that you should have an equal split. So although there's so many equilibria in the game, evidence suggests this one's important, which creates this explanatory demand. What is special about the fair split? And as I said, there's different ways people have answered that explanatory demand. But one tradition of answer comes from Brian Skirms and Jason Alexander in philosophy, people like Peyton Young in economics. And what they did was turned to evolutionary models, so ones looking at cultural evolution, to tell us why this one equilibrium might emerge naturally out of the set of possibilities in this game. And for Skirms, that was part of this larger project where he modeled the evolution of the social contract in various ways. All right, so game theoretic models typically use rationality assumptions to predict individual behavior in strategic scenarios. They typically make assumptions like every individual in a game will try to get as much payoff as possible, given what they know about the structure of the game and their opponent, et cetera, and then predict what will happen. Evolutionary game theoretic models, like those folks are using and I'm using, instead assume usually you have a group or a population. They're repeatedly playing a game. They're evolving over time via some kind of dynamics, learning or natural selection. Maybe they imitate group members who are doing well. Maybe they repeat past behaviors that have worked for them and then over time that group moves to some sort of equilibrium. All right. So in all the models that they looked at these simplified versions of the Nash demand game because it's very hard to evolve games with infinite equilibria. And in this case, I think they thought, well, there's no point. We'll just replicate the basic strategic structure of this game, but in a mini game. So if we look at this payoff table, we have two players, 1 and 2. They each have 3 possible demands, low, medium, or high. And here we'll just arbitrarily say the resource has a value of 10 and that they can demand 4, 5, or 6. The particular numbers do not matter. And then these entries track their payoffs. So if they both demand low, they each get 4. If they both demand medium, they each get 5. If one demands high and the other low, they get 6 and 4. But if they make demands that are too aggressive, they're over demanding the resource, and we'll say they get a disagreement point of 0. So that's their low payoff for pushing too hard. So we have 3 equilibria in this simplified game. Where one player demands high and the other low, where they both make medium demands, or one low and the other high. So this is how the game has replicated the original structure. You have multiple stable outcomes. They all perfectly divide the resource, and they are differentially attractive to each player. So this is the base model, and then what these folks have done in this literature is say we have a group, they're all playing this game with each other, they're learning via different sorts of dynamics, and then we see what strategies they end up adopting when we simulate or use equations to analyze this sort of model. So I will summarize very quickly the kind of thing that happens. So in these models, and this is pretty robust against many variations of this kind of model, your most typical outcome is fairness, or a population of all medium demanders, and that tends to evolve with high likelihood. And then there also is another outcome that tends to be stable and evolve, which is what sometimes people call a fractious outcome, where you have a smaller number of high demanders and a larger number of low demanders, and those two types coexist in the population. Why are these the typical outcomes? And in particular, why is fairness special? This is a hand-wavy explanation. So here's a population where everyone's using the same fair demand, and my population is tiny David Humes. And in a group like this, the group is efficient in the sense that when any individual meets any other to bargain, they always reach a Nash equilibrium. They always perfectly divide the resource. So this group can fully use any resource without any kind of conflict. Any other group, so any other combination of strategies, add any highs, any lows, you're going to have inefficiencies. So sometimes high and medium demanders or high demanders meet each other and they're jointly too aggressive. Sometimes low and medium demanders meet each other and they're too passive. So that's why the fair population is a special one in evolutionary models. And in these different sorts of models, evolution is sensitive to this kind of efficiency. So this project takes these models to explain the prevalence of fair bargaining norms and then to support accounts of social contract theory where justice emerges naturally. So it says, okay, justice is just a natural a natural property of human groups. You see it emerging in this evolutionary way whenever you have resource division, and that explains fair demands in this kind of situation and norms for fair demands. And then they do further models to outline conditions where you're not just likely to get that fair outcome, but you're certain to. So things like adding repeated interaction among group members or network models, or adding pre-play signaling, so communication before they interact, and then arguing, well, all those conditions are relevant to human groups, and that helps explain this prevalence of just norms. All right, so now let's talk about unfairness. So in philosophy, there were a couple of very influential works criticizing traditional social contract theory on the grounds that it wasn't talking about or accounting for the prevalence of unfairness or oppression. So Carol Pateman wrote this book, The Sexual Contract, showing how patriarchy tends to suffuse rules of justice across society. And then Charles Mills wrote The Racial Contract, considering the ways race has been used to organize widespread oppression and inequity. And so, for example, in that he points out, you have social contract theory. People are talking a big game about the equality of all man and justice in contracts. But if you look at history, of course, people of color are often not included in those social rules of justice. And these kinds of phenomenon that these philosophers are talking about are widely recognized. So across the social sciences, it's widely documented that in every society, there are types of people who get more and others who get less. And there are norms and conventions supporting these unfair divisions of resources. So this introduces a new explanatory demand, which is what we'll turn to for the rest of the talk. We've seen this ubiquity of fair demands in bargaining models. Why do we see so much inequity when we go look at the real world? I mean, both things are there. You do have these norms of justice, but you also have norms of injustice. And looking at these two books gives us a hint of what to do to explain these two things together. So both of those accounts of unfairness related to social categories, to gender and to race specifically. What we mean by social categories are categories of humans widely recognized within a society where members of that society use those categories to guide their behavior toward others. And in most societies, in every society, you have what sociologists sometimes call primary social categories, the ones that are most important in shaping interpersonal behavior. And particularly what you see is people conditioning behavior on the basis of these categories. So treating different sorts of people differently, even when they're in similar interactive contexts. If you look across societies, gender and race basically always constitute primary social categories. And then gender and age do. Very commonly, you'd also have categories like race, class, caste, or religious affiliation acting in that way. So we're going to add these to evolutionary bargaining models. In most types of evolutionary models, you assume a single unitary group of actors interacting and evolving. But to capture evolution with social categories, you want a model where you have different types or tags. So individuals with some kind of marker saying, I'm a different type from this other individual. So there was an early influential model along these lines, the emergence of classes model from Axel, Epstein, and Young. And what they did is took a group, had them play this exact same kind of Nash demand game, but instead of having one kind of actor, they would now have two recognizable types of actors. So they'd have David Humes and they'd have Rousseau's. And they'd assume, well, each member of the population can condition their strategy. So they can pick a different behavior based on the type of opponent they're interacting with. So there isn't anything else about these tags except that they allow recognition and conditioning by other actors. There aren't other properties associated with them in this model. Now, when you evolve this kind of model, the addition of just this sort of thin tag shapes evolutionary outcomes. So now you have a brand new set of equilibria. So when you look what happens within each group, how they treat each other, it's the same as the single model. So you usually get fairness, sometimes you get fractious outcomes. But what's more interesting is what happens between groups in this model. So now you have separate equilibria between the groups, and they can match either of the any of the sort of basic equilibria of the model. One group demands high whenever they meet the other. They make fair demands of each other, or one group demands low and the other high. And notably important here is that two of these outcomes can provide what we might call a minimal representation of something like unfair or discriminatory conventions. Because at these outcomes, you have one group systematically getting more at the direct expense of the other, and built into the model, there's no kind of justification for why one group should be getting more. The only reason is that they're in these two different categories. So here's what that kind of outcome looks like. Look, in philosophy, we're not necessarily big on images or figures, so you just have to take these in that context. So you have Humes, they're all playing fair with each other. The Rousseaus are playing fair with each other. But when they interact between the two types, the Humes always get high and the Rousseaus always get low. And notice that because of the presence of these types or tags, now we can have low and high demands in this population, and it's still entirely efficient. So we can have low and high without them miscoordinating, because the presence of these types allows them to coordinate on unequal splits. So when you have the model with one group, that symmetric fair outcome is special, but once you add tags, they create a symmetry breaker. They allow for rules like Humes always get more, Rousseaus always get less to be efficient. So now the actors have some way to coordinate unfair expectations on the basis of these social categories. So in their model, what Axtell, Epstein, and Young show is that these kinds of discriminatory conventions emerge robustly in models with social categories. So they looked at one particular kind of model, but they found that these kinds of unfair outcomes have significant probability of emerging in that sort of model. And then there's been a lot of subsequent work, much of it by me and my group, showing this is a robust, widespread result and exploring various aspects of what you expect to happen in these models. Now, notably, for unfairness to emerge in these models, you need what we might think of as very minimal preconditions. You don't need the actors to be particularly biased. They don't have to dislike their outgroup. They don't have to have in-group favoritism. What you need is the presence of these tags, so some kind of bare bones social category. You need conditional behavior, the ability to make different demands in response to different tags, and they have to be able to learn to benefit themselves. So, in the book and elsewhere, part of what I argue is that these are ubiquitous factors in human society. They're pretty hard to eliminate, and that this kind of model helps explain the ubiquity of unfairness in real human groups. So I'd say the important takeaway here is that if you have social categories, inequity isn't actually hard to generate. And these sort of simple models of evolutionary bargaining do not generically predict fairness. Unfairness is also possible. And in fact, I argue more unfairness really is what you'd expect in most cases where you have evolutionary bargaining between groups. And part of what I'll do in the next section is introduce a set of results that push us toward that understanding where really what you expect to come out is categorical unfairness. All right, so let's talk about these models, the power and unfairness models. So in this paper with Justin Bruner, he and I looked at these sorts of models and added a powerful group, changed the power of one group, and showed how powerful groups tend to evolve to get more resource. And then Travis Lacroix and I extended this to situations where you have heterogeneous groups. So, in the models with Justin, we looked at models where everyone in the group is empowered in the same way. And in the models with Travis, we looked at situations where you could have variations in power in groups, but maybe one has more than the other. So to look at this, obviously we had to add power to our models, but actually power is a pretty complex concept that corresponds to a bunch of different sorts of things when you look at actual people. So what we did was operationalize power in a bunch of different ways and looked at how all those different ways impacted evolution. But what I'm going to talk about here is just one of those ways that has been used traditionally in economics in this model and also corresponds nicely to two senses of power in philosophy. So the most common way philosophers break up power as a concept is power to versus power over, where power to is something like an individual's personal empowerment, their ability to act, to do as they like and get what they want. And power over has to do with relationships with other individuals, so the ability to get others to obey your will or go with what you want. So as I said, I'll just introduce one of the ways we did power here that can go with both of those senses. And this sense of power involves having different disagreement points in this model. So this goes all the way back to John Nash's work on bargaining. And part of the idea is if bargaining fails, if I can expect a better fallback position, that might give me more control or influence over the bargain. It makes the bargain less important to me than it is to you. And therefore, I might be able to get what I want more. These differences in fallback position can arise from background facts about the actors. So maybe one actor just has more money or better social status or has political empowerment or has more friends. And all of those things could put them in a better position when bargaining fails. So in that sense, it can correspond to power to individual empowerment. Nash also pointed out that these differences could arise from threats that the actors would make if the bargain fails. So if this bargain doesn't work, I'm going to do something to you. And part of what he thought was, well, if someone can make a more credible threat, then they should have more power over the bargain because they can decrease the payoff of the other player upon failure. So also these different disagreement points, or in that case, threat points, could arise from power over another individual. So what we do in the model is we have the two groups, we hold the disagreement point of one group fixed, and then we increase the disagreement point of the other group, make them more and more powerful. And we evolve these models at all of these different parameter settings and see what happens to the expected evolutionary outcomes. So here's a little figure showing the main result, which is the more powerful a group is, the more they tend to evolve to get that high demand rather than the low or medium demand. So on the x-axis, we're increasing the power of the powerful group. On the y-axis, we're showing those three evolutionary outcomes, the three equilibria. So as power becomes higher, the fair equilibrium drops off. The equilibrium where the powerful group gets low goes to 0. And the equilibrium where the powerful group gets high becomes more and more prevalent. So power translates into an economic advantage with respect to social norms and conventions. And there's different results in economics arguing, well, power gives you a bargaining advantage, but it's different because that is looking at sort of individual bargaining between individual bargaining between two agents based on effects on sort of rationality and interactive expectations. And this is about what happens on the social level, social conventions or norms for expectations about who gets more. Why does that happen? In these models, the powerful group has relatively little incentive to learn low demands. So there's not a big difference between their disagreement point, bargaining failing, and the low demand. And so you see them not very quickly learning to make those low demands, and that translates into an advantage for them in when you're looking at learning patterns through the model. And notably, this kind of pattern can arise if you add just a few powerful individuals to one group. So if you make them, if you give them a bunch of different levels, but make one more empowered on average, you get this effect. But you can also just take the two groups and add one powerful person or three powerful people to one and get this effect. So Travis and I built these models thinking about cases where, say women are on average less empowered than men, but some women are quite powerful. The entire group in this kind of model ends up disadvantaged by the norms that emerge, even those individuals who themselves might have very good resources. So this is a model where we had two identical groups. We added one powerful individual to one group, and then on the x-axis, we're increasing that one individual's power. And we see basically the same effect replicated. This particular model has different dynamics, different population size, but again, the fair outcome drops off, and the outcome where the group with one powerful individual gets high becomes more and more prevalent. What I do in the book is extend this sort of model to think about how power might compound and reproduce itself in groups that gain some sort of advantage. What I do here is assume you have two groups and where they might evolve to bargain multiple times in different sorts of arenas in their lives. And in these models, I assume if a group ends up demanding high in one set of interactions, that's going to raise their disagreement point for future interactions, which should make sense. So if they get some sort of economic advantage in one kind of interaction, they have better fallback positions for future bargains. And what happens in this kind of model is that one group always becomes systematically empowered. So they end up being the ones with a high disagreement point, winning most evolutionary outcomes. And that's true even if you start the groups perfectly symmetrically. You always get some kind of symmetry breaking and one group becoming systematically empowered. And then also I look at what if you make small initial differences between them. Say one group we assume is slightly economically advantaged. Those end up mattering and quite strongly predicting which group becomes the powerful one in the end. And then in follow-up work, Justin Bruner, who I mentioned before, and Liam Bright and I also use this framework to think about intersectional disadvantage. So do people with disadvantaged identities that intersect experience particularly acute disadvantage as a result? So we built models where you could have multiple tags that might represent, say, race and gender, and each one could be associated with some kind of power or disempowerment. And we found that we would often get effects where having a doubly disadvantaged intersectional identity would be worse than either unitary identity in non-additive ways, which is a key thesis of intersectionality theory. So, general takeaway, power asymmetries between groups tend to promote unfairness. They make it generically more likely to emerge. And even if you have initial absence of such asymmetries, they will and can emerge if given enough time for interaction in these models. Given that power asymmetries and just asymmetries in general tend to be the rule in the real world, I argue that these kinds of models support this picture where unfair contracts are really what we expect to be happening naturally. So I take this to add to this critique of this evolutionary justice literature. So you might respond, well, in this kind of model, you can't get these unfair conventions unless you have social categories in the first place. So in cases where you don't have salient social categories, or if we could get rid of social categories, maybe we'd return to these one population models where fairness is what you'd expect. But this set of models also illustrates how social categories can emerge and how there are a lot of conditions where you expect them to emerge endogenously in order to regulate bargaining. So there's this paper by Popa, Bullenberg, and Wyatt, Fairness and Signaling in Bargaining Games, where what they do is look at variations on tags and what tags look like, and consider the information content that various tags include and how that influences whether and how unfairness can emerge in these models. And in general, they argue, well, tags have to carry a certain amount of information about group membership to allow for inequity. So if you have tags that are flexible or hard to read, you're less likely to get unfairness. And so my group used their kind of models to look at the cases where you expect tags that are inflexible or easy to read to emerge. So what kind of tags are we talking about here? So far I've been talking about a picture like this, where it's like you have groups, everyone knows who's in what group, everyone is able to condition their behavior very easily. You could contrast it to a picture like this, where you have Humes and Hume stars, and maybe these groups are kind of hard to distinguish. So when individuals interact, maybe they are better than chance at perceiving whether that person is an in-group or out-group member, but sometimes they mess up and they treat an out-group member as an in-group member or vice versa. Or maybe you have a situation like this where individuals can update their tags. So a Hume could become a Rousseau or vice versa, and maybe there's some difficulty level of how hard or easy it is to switch groups. So their general takeaway, when tags are less flexible, so harder to adopt, more heritable, they're passed on in groups, and more observable, easier to see who's what, you tend to get these unfair bargaining rules emerging. So if, for example, everyone can switch tags when they want to, if you have a group getting low, they can just change their tags and get better payoffs. So with Liam Bright, with Femi Taiwo, and Nathan Gabriel, what we did was use these models to think about a particular type of tag and how it would emerge over cultural evolutionary time, and that was race. So if you look at the way race is instantiated, especially in the West, it tends to be difficult to change, so inflexible. It tends to be heritable, passed on to offspring, and it tends to be easy to identify. So we argue in this paper that that explains why race, as opposed to other possible categories, was chosen and then developed as a locus for oppression. And we think it helps explain why race as a cultural construct has the features it does that make it inflexible, heritable, and easy to identify. So part of the idea is that you might have situations where you have different groups, maybe a more powerful group, as in the case of colonialism, where inequitable systems are developing, systems where some actors want to get more and others are going to have to get less. And for that to happen, you need something to stabilize that system. We know those systems aren't stable unless you have some sort of social category to hold them in place. We ask, why would something like race be the thing that gets selected in cultural evolutionary time? And answer, well, it has the right sorts of properties to hold these discriminatory equilibria in place. And thus, we see things like race getting picked and developed in order to play the role of stabilizing inequity. So for example, one of the models we look at, we say, okay, these groups have different sorts of tags. And there are, in particular, different tags a powerful group might learn to pay attention to in bargaining with this outgroup. And we ask, are they going to evolve to pay attention to the kinds of tags that support inequity? And in this particular model, we do a bunch of different ones. We'll say there's reliable tags, ones that always identify the outgroup, and unreliable ones where sometimes you're going to mess them up. And we have them evolve to pay attention to different tags. And we find that they tend to evolve to pick the reliable ones, the tags that can underpin inequity. So this shows these results. So here on the x-axis, we're making the tag of the less powerful group less and less reliable, so easier and easier to mess up. And then on the y-axis, we show how often that tag gets picked versus some other reliable tag. And we see powerful groups being less and less likely to pay attention to a tag if it's not the kind that can underpin inequity. And in particular, the more powerful the group, the more they pay attention to these inflexible tags, ones that look like race. So here, these different traces are different levels of power for the powerful group. And so here's the most powerful group. They do not pay attention to the unreliable tags very often. So takeaway here, even in the absence of existing meaningful social tags, if you have any kind of tag that can turn into a meaningful social tag, cultural evolutionary pressures may lead to the emergence of the sorts of categories that can ground and stabilize inequitable contracts. So altogether, this contributes to this picture where unfairness is easy to get. You can evolve the tags to support unfairness. If you do, and you have any asymmetries between groups, the expected evolutionary outcome is unfairness. So one thing I've argued is that when we think about countering unfairness, we shouldn't talk about this as something that we can just do and then be done with. Instead, we should think of unfairness as a natural process, natural not in the normatively good sense, but in the statistically likely sense, something that we expect to have its own logic and keep emerging on its own. And so when we think about equity, I don't think we should think of that as a state we can achieve, which is how a lot of people talk about it. What would equity mean? But rather as a process we're engaged in. So there are these cultural pressures that push towards inequity. And so what we want to be achieving is a continual pressure against those processes. So I will wrap up. Because of the presence of social categories, we shouldn't expect emergent contracts to be fair or just. This helps square this earlier evolutionary game theoretic work with these kinds of critiques from folks like Mills and Pateman. These two things actually fit together perfectly well. You do expect fairness or justice in some conditions, but not in others, and in particular, not across social categories. Power asymmetries between groups tend to increase the probability of unfairness emerging. Power asymmetries tend to emerge, and social categories themselves culturally evolve to underpin unfair systems. And with that, I will say thank you.
Thank you. Thank you, Cailin, for this very clear and insightful talk. And now we have roughly 15 minutes to discuss and answer the questions from the audience. So if you have any, please just feel free to unmute yourself and raise the questions. If there are no direct questions, there is one from the chat from Priya. Why don't the powerful group correct this towards more fair if they see the position as unfair? From the chat box.
I'm guessing that was happening in the context of a particular result. Maybe Priya, you could clarify.
Yes, thank you, Professor. So, I'm curious that you had mentioned this position where there are two social categories, and one category, if it is powerful, then that initial difference will escalate and the power increases. And that leads to unfairness. But I am curious, if this is the position, then over time, the unfairness would be understood by the group which has power, and wouldn't they try to make it more fair?
I mean, you tell me, is that what people do? I
But
mean,
that's not, so I asked this because otherwise the balance between them would be lost and there would be what we could think of as war and things like that, right?
oh, yeah. Okay, good. Yeah. So, I mean, obviously in these models, there's no incentive for anyone to avoid systematic or long-term unfairness towards another group. And
Mm-hmm.
if you look at the real world, people have pointed out there are situations where you have unfairness, and if one group gets too oppressed, then they have so little to lose that they tend to do other things like revolution or, some kind of violent resistance. And so that's not in the model, but I think you correctly point out that although in these models unfairness is stable, there are things that can destabilize unfairness that are other social factors that we do in fact see coming into play in some situations. Yeah.
Mm-hmm. Okay, okay, all right. Thank you.
Thank you.
Okay, the next question comes from Aliyah.
Hi, thanks for the talk. I enjoyed that. Maybe I just wanted to press Priya's question a little bit. So I'm just wondering, you mentioned that equality is something like a process. I think that's a nice point. Do you have ways of modeling what like a social justice mechanism might look like in simple models that you presented?
Yeah, so I haven't done this. I have written some stuff thinking about, all right, in this sort of model, if you wanted to think about change and what that would involve, what would it look like, and how does that correlate to how we see actual movements for social justice or equity in the world? So there's a whole set of models on social justice that mostly talk about solving free rider problems in collective action. I mean, the things I talk about, which are not like the most mind-blowing insight, are things like, well, you have to recognize in situations like this that you're, even in the real world, approximating something like an equilibrium where everyone's incentives are not to give up what they've got. And what that means is that if you're talking about things like just moral education, that doesn't necessarily disrupt an equilibrium on its own without some kind of action or change, right? So you can tell people all day like this thing is unfair, but unless someone actually changes what they're doing, the pattern isn't disrupted. And so I argue, well, I mean, this maybe helps explain why when you look at justice movements, they involve actual changes in patterns of behavior, changing payoffs to another group for continuing at the same pattern that we're at or something like that.
Thank you.
The next question comes from Laura.
Hi, thank you very much. I was wondering a couple of things. I was wondering, did you all also try your models within context independent or culturally different contexts? Does sort of unfairness evolve in the same way? But then, just because the question before made me also think while listening to you that applying Rawls' veil of ignorance would be one model to get rid of the tags in a way that one could try it too. And you don't have to answer to all the questions, but just pick one you want. The third thing I'm interested in from my own research is if you imagine a group like a collaborative research group where money shouldn't play a role, gender shouldn't play a role, they all have a joint epistemic aim to get the research out in a constructive way, but still there is a lot of power and strategic between or in these groups. So I thought it would be interesting to have you reflect on that situation, how you explain that.
Okay, well, I'll address the last thing first, because actually the first models that I was doing in this area were specifically of academia because I'm a philosopher of science. And so I was looking specifically at the division of outcomes of collaboration. And that first power model, Justin and I were considering outcomes of collaboration across power groups like professors and graduate students, for example, or potentially people at more powerful universities with more money. And so if you want, I can like give links to some papers where we specifically think about how you would model that. As far as something like the veil of ignorance, I mean, these models, because they're cultural evolutionary, like I'm taking them to be about things that can actually happen, you know, in human cultures. So I take it a lot of people agree that if they were behind a veil of ignorance, that they'd want to pick a fairly equitable culture, but nobody is ever. And so they're in a real culture. And given that, they don't actually want to pick that a lot of the time. In fact, what they want is the thing that's good for them, plus some kind of justification that makes that thing okay. So yeah, I haven't looked at something like that.
Thank you, Nora. And Marco, please, your question.
Thank you very much, Cailin. I found the presentation really interesting and very relevant to my work. So I wanted to go back for a moment to the model that you described by Axtell, Epstein, and Young, the 2001 paper. And it seems to me that in the absence of any power asymmetry, the model has three possible equilibria, one of which is fair, and then the two unfair equilibria. And I was wondering whether, like, what's the likelihood that the population will end up in the fair equilibrium compared to the unfair ones? Yeah. And if there are factors that make, even in this basic model, the unfair equilibrium more likely?
Yeah, good. So it depends on variations in the game, like what are the actual demands, how many demands are there? So if you look at variations where you have different sets of demands, the basin of attraction for the fair demand, that's always the single equilibrium that's largest. And then whatever's like closest to fair has the next largest ones, then whatever is next closest to fair has the next largest ones. So fairness still has a kind of pull in this sort of model, but it's often the case that unfairness taken all together is more likely, even much more likely than fairness when you have the symmetric model. It depends on how you've divided up the possibilities for unfairness. And it depends also to some degree on learning dynamics, evolutionary dynamics, and population structure that can make, you know, basically non-systematic impacts on how likely the things are. And so in argumentation, I haven't usually drawn conclusions too much on the basis of that, because I'm like, well, they're arbitrary changes that they're hard to kind of hook up to whatever is happening in the real world. And so I'm like, the main thing we're worried here is just this very robust thing, add categories, get inequity, and get it like pretty common in many variations of the model.
Right, yeah.
Yeah, one other thing that impacts it, which I didn't talk about today, but my group has very systematically explored, is group size, whether one group is smaller or larger. And basically what group size does is impacts speed of learning compared to the other group. So smaller groups interact with their outgroup more than large groups do. And that means they learn quicker, and that changes the expected outcomes in these models.
Yeah, I'd love to talk to you about all these different variables. Assortativity, for example, how often do you interact within group relative to out group? But, you know, if I can, I have another quick short question is, the Nash demand game is a non-zero sum game. We have a certain amount of resources to split between the two of us. But I would imagine that a lot of games are non-zero sum, and that there might be benefits, collective benefits, to have a fair division of resources compared to an unfair equilibrium. So I wonder, how well do you think these results can be generalized to non-zero sum games?
Yeah, so I mean, yeah, as you point out, Nash demand game, like all these other games, is non-zero sum, but you could imagine versions where, so I think this is what you're getting at. You could imagine versions where there are synergies from fairness. Like, for example, if everyone's expecting to get quite a lot of the resource you're all producing, then they'll work harder, maybe. So if we imagine a version of this game where you're first producing and then dividing a resource, it might be that the resource is larger when you're closer to those fair splits and the resource is smaller at the unfair splits because someone's like, why am I bothering putting in the work? So I think that if you looked at that variation of the game, I'm almost certain what you'd get is like a push towards fairness. And so, there might be arguments that there are certain kinds of cultural interactions or places where fairness has more pull because of this thing where people could withdraw their labor when things are too unfair.
Thank you. That's a very hopeful answer.
Yeah. Well,
Okay, so the next question comes from Zarin. Sorry if I mispronounced your name, but sorry, we can't hear you.
Am I audible now?
Yes.
Yeah. Okay. So I actually have two questions. Hope that's all right. I'll just briefly go over them. So firstly, my first question is actually quite similar to what has already been discussed, but I was wondering if there are ways to introduce incentives within game theory models which has inequalities embedded in them so that individuals are more likely to cooperate even when they do have uneven power dynamics or even when individuals have more power over another. There are some cultural evolutionary theories which talk about, for example, the benefits of cooperating or contributing to group fitness in relation to the increase in one's own fitness. But I was wondering if there are ways in which we could incentivize individuals to reduce inequalities, as it were. That was my first question. My second question is, a lot of the evolutionary game theory models that I've come across actually look at cooperation at an individual level, and I was wondering if these models could be replicated or if models could be created to look at international relations in terms of diplomacy and negotiations, for example, and how the power dynamics among different countries contribute to negotiations and why and how countries cooperate when they do, despite these forms of inequalities. Thank you.
Good. Good. Yeah. So for the first thing, like, are there ways to incentivize individuals to move towards cooperation? And so, like, basically to shift what you expect to happen in these models by shifting individual payoffs. So, I mean, there's two ways to think about how that could happen. One is like actual literal physical payoffs, which usually when I'm doing these models, that's what I'm thinking about, like material payoffs that then change who's going to imitate who and who's going to repeat what behaviors. And then another thing is what people like or prefer to get, trying to shift that. So, you could imagine ways of setting up material incentives for fairness. Like in your company, you could just literally pay people or give them, advantages in promotion if they behave fairly, say. Or in academia, you could have structural incentives so that people don't take total advantage of their graduate students when writing papers. So I think you can think about adding those. And I think the last question was relevant to that. Like maybe there are scenarios where you would get shifts in what the payoffs are based on whether you're moving towards fair and unfair outcomes. You can also think about, so people talk a lot about like, just teach people that unfair things are happening, and then that will shift their perception of what's happening, which will shift their preferences for certain outcomes. I'm like more skeptical of this as a solution to unfairness because I tend to think that like moral education, people just find ways around it when there are material incentives that don't fit with what is morally good to do, and if they can get around it. But that's another way to think about that. As far as like modeling nations interacting, I mean, sometimes people do use bargaining games to think about international interactions. It's pretty tricky though, because you have to somehow think of nations as having payoffs like they are a unit, a unitary agent, and also as having strategies and also as updating those strategies, like having dynamics, and all of that gets interpretationally a little tricky, I think, but that said, some people do it.
Thank you so much. Just to quickly follow up on your first response, you talked about material, like introducing material incentives to move away from inequality in a way, but I was actually thinking more about social contract theory, or for example, our day-to-day interactions, or just broadly societal interaction, like broadly interactions within a society. So not necessarily within academia or within a company, but society as a whole. So are there ways in which we could incentivize individuals to move away from inequality within that context? And especially you had mentioned social contract theory before. So I'm wondering if, for example, within social contract theories, there are ways to introduce incentives which address inequality.
Yeah, I mean, one way you can think about some of the results of social justice movements is changing incentives by changing social censure and like feedback that people get. So if you know that like if I treat someone unfairly and then it gets noticed or I get caught, I'm going to get serious social censure, that does change your payoffs. So that's one way to think about like the effectiveness of something like call out culture, or is that responsive?
Yes, in a way, yes. I actually have a lot of questions that I'd love to ask you, but I don't want to take up more of your time. So thank you so much for your response.
Okay, so we are indeed a little bit over time, but if we can keep the questions answers super short, I guess we can still make it. Cailin, do you think you can still take? Okay, then Dom, please go ahead. If you.
I can't hear.
Sorry, we can't hear you.
Thanks for working so hard to pack so much into a short talk from so much. I posted a question in the chat, and thank you for sending the paper, but I know that paper, and my question in the chat wasn't very well, I didn't frame it properly. When I was talking about cross-cutting tags, what I had in mind was not intersectionality stuff, nor, as in that paper you posted, kind of true meritocracy, which doesn't work for the reasons you indicated in your paper, or that are suggested in that paper. I'm interested in noisy meritocracy, right? So probably the kind that a lot of people have tried to actually pursue, right? Where what happens is you get a hard to achieve proxy that's taken to be representative of merit, and that is maybe achievable by people who have been stuck with the inflexible tagging system that put them in the disadvantaged group. So I'd be interested more in I'm asking if you've done any work on the evolutionary dynamics as such tags start to be introduced, right? Where there's a new cross-cutting tagging system, and over time, the disadvantaged group can try to acquire those tags instead.
Okay, good. Yeah, that's really interesting. I haven't done work on that, but I take it would be relevant to thinking, I mean, if your university degree is the new tag, and it's something that you set up in such a way that it's maybe not achievable by everyone, but people from both groups, there are going to be some people who can achieve it, that it could act as like something that disrupts this kind of system, like creates new logics of inequity that disrupt the old ones or something like that. Yeah, I think that's interesting. I also think very interesting, which I haven't done a ton of modeling about, is the ways that class markers can be adopted, changed, shift, co-opted to either enforce or disrupt these kinds of systems. So often people use class markers, things that are hard to achieve, like expensive clothing, or an accent that might be hard to adopt, if we look at England, for example, to try to enforce these groups, even when you don't have something like race that's like very easy to observe. You create your own things. But then there's all sorts of ways that people subvert those by getting the clothes or by learning the accent. And so there's ways in which the groups can kind of pull those apart. So I think there are like fascinating dynamics there, but I just haven't really modeled or worked on them. And to some degree, these models, like there are places where adding real complexity, I think, makes them, like the models themselves, less informative. And I'm in the kind of the keep it simple, stupid type of area. Yeah.
Okay, our final question of the day comes from Brian.
Okay, just quickly, and to focus, since you're interested in the social categories, whether something you've done or could be explored where you can get like elite contestation, either within elites or between elite groups, and whether you can get dynamics like you alluded earlier, people getting too upset, too exploited, which gets back to like the work on ultimatum games, which appears to be culturally dependent, which is interesting. Though it means it may not be as nice and tight as the kind of models you're doing. And another version would be Mansur Olson's Stationary Bandits, which again is like a payoff function to not be too greedy, things that can act. And then you can also get power against power, checks and balances model, which gets into governance. So any things that seem interesting to explore?
Yeah, I mean, so I think I'm less familiar with this, but I think Peyton Young and Related have looked some at these dynamics of the like not leaving enough meat on the bone then prompts negative responses or prompts groups to try to escape unequal systems. Like it's definitely a dynamic in the real world cultural realm that you see repeated across a bunch of different places and like an important dynamic. But again, like part of the reason I haven't looked at it is that, like, you know, with the sorts of models I'm using, I'm a little bit the person looking under the lamp for their keys. I'm like, I want to use these models in a way where I think the model can inform the thing I'm looking at. But I think there's some kinds of complexity that if I add them, that the model is no longer informative. And so for that reason, I've stuck more to the sorts of projects where I'm like, okay, I think this could be something that tells us about something. Yeah.
Thanks.